So I'd just like to say a very warm welcome to Stephanie Hazlitt. Stephanie is the Director of Data Science Partnerships at British Columbia Stats, the statistical agency of the British Columbia provincial government. Stephanie is a PhD data scientist, researcher, educator, and leader, and her passion is for developing and contributing to reproducible and user-focused data science products and open source software. She uses R in her everyday work for over a decade and is passionate about supporting people and teams to be productive in creating and sharing and communicating research. Welcome, Stephanie, and we're looking forward to your talk.
Thanks very much for that lovely introduction, and good morning and happy Friday to everybody in Australia. Please, I'm not monitoring the chat, but I'm sure that others are, and so if there's any sound or slide issues, please let me know, and I'm happy to stop and pause at any time. So as we said, I'm going to talk a little bit today about building data science capacity within the British Columbia Public Service. And where I've worked on and off, mostly on for the better part of about 15 years. And I thought I'd start the talk by introducing the BC Public Service. So I am calling in from Victoria, British Columbia, Canada. So the map on the left is the province of British Columbia, the westernmost province of Canada, and the dot is the city of Victoria. If Wikipedia's numbers are right, the province of British Columbia is about the same size as the state of New South Wales. So very big, has about 5.5 million people. And the public service, or the BC Public Service, is the professional organization that supports the elected provincial government of the province. It's comprised of about 20 plus ministries, ranging from natural resource sector ministries like Ministry of Environment or Ministry of Forests. Australia has many of the equivalent, to social ministries and finance ministries. It has over 35,000 employees, and many of the roles in the BC Public Service involve data, creating data, data administration, sharing data, data analyses, research, and beyond. So that sort of sets the stage of where I'm coming from, and a lot of my talk will be influenced. We'll have a kind of a public sector organization feel to them, but I'd love to chat with others who might have similar lessons learned from other types of organizations. All right, so I started thinking about this talk, and I thought, I know why I think data skills are important for the public sector, but lately I've been asking ChatGPT to verify my thinking for lots of things. So I asked ChatGPT, why is it important for public sector organizations to build data analysis and data science skills capacity? Can you provide an explanation suitable for sharing in a virtual presentation where I only want to talk about this for a couple of minutes? I'm really working on my prompting skills, which is kind of why I use ChatGPT. So very politely, they say, certainly, here is a concise explanation. Public service organizations need to build data analysis and data science skills to make smarter decisions, optimize resource allocation, and enhance transparency. By harnessing data, they can be better understand community needs and improve service delivery and prevent fraud. And it goes on. Pretty good answer, I actually thought, and quite strategic, and makes me feel really good about where I put a lot of my time since I have a position that's paid by taxpayers. It's not really why I started the work, or wasn't really the motivator for me. My motivator started much more kind of operationally or almost personally. So I'm going to talk a little bit about me. Everyone can call me Steph Hazlitt. And this is a little bit of my career path in R. So I actually started my career as a bird biologist for a few years here in Canada, mostly studying shorebirds. Hence, all of my public-facing avatars are still a black oyster catcher, which is one of my favorite shorebirds that I've worked on. Later, I decided to go back to school and do more environmental research, and so I actually trained and did my PhD in Brisbane, Australia at UQ. Some of the most amazing years for me, chasing brush-tailed rock wallabies all around Queensland and New South Wales. And then only after I finished school, I went on and I joined the BC Public Service, first as a conservation specialist, sort of leveraging that education that I had. But I quickly moved into what's called state of environment reporting, something that's very similar between Canada and Australia, are legal obligations to report on the state of environment at different jurisdictions, so for the Commonwealth or also for states or provinces. And that's where my journey with R really began. And so I went on and to become a data scientist, and really now I'm mostly in management, and so I spend a lot of time in meetings and trying to code as much as I can. But so this is a lot of what I'm about to share today is sort of taken from this journey from biologist to data scientist. So when I started working on state of environment reporting was when I really started to pay attention to the workflow from starting from your data to communication. When I was doing my research, I was always just heads down, sort of getting things done, get the data, use whatever tools you need to write your paper and put it out. But when I got a job, and my job was to sort of report on things with bigger data like air or groundwater, where you have millions of rows of data, and it became very important. People would ask you questions about that analysis, people who didn't like your results. All of a sudden, things felt really different for me as a data analyst. And it felt different because this is, I think, a really common workflow in many organizations, and certainly was for me when I was doing my research. You would collect some data, or a business owner would give you some data. So here's the data for the work. Maybe it comes in Excel or CSV. And then you would use a suite of tools, all excellent tools for the job that they do. But when you're sort of moving from data to communication, all of a sudden you need quite a few tools. And so maybe you do something in Excel, maybe you use R or SAS for some statistical analyses, which is how I was introduced to R originally. Maybe you use Esri to make a map, and then you write something in Word, and then you have to publish it to the web. So maybe you have to write some HTML or make a PDF. And then sometime later, maybe you're halfway through or two-thirds of the way through, and that business owner says, "Oh, sorry, I gave you the wrong version of the data. Have to start again," which is sort of a joking way. That doesn't maybe happen too often, but maybe you need to redo the analysis in 3 months or 6 months. And in the case of state environment reporting, there's a real push to increase the frequency of indicators and our use of data on the environment. So I really had a sense that there was a better way. I knew there must be a better way. All this cutting and pasting and clicking, and and I knew that mistakes. You really want to avoid mistakes with your data. And for me, a lot of it began 10 years ago. And actually, when I was making this, and I pulled this tweet, I'm not on platform X anymore, unfortunately, but it does still document some of my past. So still pulling from some of my public record. And so on March 26th of 2014, so almost exactly 10 years ago, I tweeted about attending what was called a software carpentry boot camp at the University of Victoria. So I was working for the public service, and a bunch of myself and a bunch of my team were invited. I didn't really know what it was, but it sounded interesting. And it was really the beginning for me. And it was career changing. So for those that don't know, the Carpentries is a not-for-profit, I believe, organization that really tries to bring computer skills and software skills to scientists, to help scientists do their work more efficiently, do their work faster, and do their work more reproducibly. And that's what I learned on that day. And honestly, I've been, when I reflect, that completely changed my focus of things that I was passionate about, and my focus of how I wanted to do my work and what skills I wanted to bring. And that has really stayed, it's just something that have really stayed with me for the last 10 years, whether I've been a data scientist or a manager of a data science team, or all of those things. So I'm going to sort of give the story away, which is since that time in 2014, over the last 10 years, we've seen a real growth across many of the ministries and the BC Public Service writ large of the use of R. And the use of R, I'm going to say, sort of more in production. So not just for statistics, but for building out automated data pipelines, for publishing reports, and for or publishing dashboards. So I don't have a tidy table of quantitative data on any metrics of our users in the BC Public Service, unfortunately. But I did put together some qualitative information, which I'm kind of presenting here as landmarks over the last 10 years. And so we can start with 2013, back when I joined the State of Environment Reporting team. I mean, there were many teams using R. I don't want to at all suggest that the public service wasn't using R or other programming languages, often for statistics and part of a broader workflow. But there weren't really any places to go about how would you build out an automatic data pipeline or keep something up to date or something that was fully reproducible. And so after some training and this sort of eye-opening experience, my team started to use R and leverage R for rebuilding state of environment indicator workflows that were fully reproducible. And then we really wanted to be able to publish those along with the indicators so that other jurisdictions or other researchers could see what methods that we used, they could interrogate them, they could reproduce them. And so in 2014, the BC government opened an organization on GitHub, Microsoft's code-sharing platform. And actually the first repository that was pushed to BC Gov GitHub was a groundwater indicator repository using R code. Now, BC GitHub was originally launched to help government better collaborate with the tech sector, you know, how to make tools better and faster, but it quickly became a dual purpose of really providing a place for open science and open research to happen for government. And so once we got into GitHub, things really started to expand. We started to see a lot of HTML sort of web reporting sites being built using code, or reports being built with code. And then a few years later, my team had built some R packages to facilitate those workflows, and we were able to bring comfort to executive in our government to publish those R packages to CRAN, which I'll talk about a bit later. And then we launched our first Shiny app built with R, which was in 2017. And then shortly after that, we procured shinyapps.io so that other groups in government could publish Shiny apps and build them. And by 2019, it was clear that we had sort of cottoned on to a workflow and tools, and something was working well. And so we launched the Data Science Community of Practice in government. And now we're in 2024, and I've stopped keeping the graph up to date because I can't even count how many teams and how many ministries are leveraging, whether there are tools or Python workflows or other related workflows. So I'm going to spend the rest of the time talking a little bit about how did we get from sort of 2013 to, you know, a few people using R for statistics to where we are now, which is a workflow that's like approved and really well leveraged across the BC public service. And how did we get there? I'm going to start, and really this is sort of what's, you know, how some of the things that I think have played a key role. And one of them, if you're, you know, in an organization and you're interested in growing data science capacity or other kind of, or digital capacity or data literacy, is to really encourage those early adopters. And we all know who they are. If you're lucky enough, you'll recruit somebody and they'll have passion and they'll bring new tools and ideas and they're trying something out. And I really feel like this is like foundational to bringing change to an organization. So early adopters are, you know, individuals or groups within your organization who enthusiastically embrace new ideas, technologies, or practices before they become widely accepted or mainstream. It can be sometimes easy to like not pay attention because you have your tools and everything's working, and it takes capacity and it takes time, you know, to assess new tools and to assess the return on investment. But I really feel like these are our leaders who change organizations one team at a time. My next observation is really pointing those early adopters so that we're helping solve a real problem in your organization or in your team. And so in the public sector, we have the same problems as most data teams, I think, anyways. And if you can solve a problem that everyone's having, then people will want to learn a new tool. They will want to increase their skills. They will change how they work, but it really has to help. I think we all know that to sort of like change a habit has to be, you have to have something that really compels you to try it out because it's hard. It's hard to change. It's hard to build new skills, particularly when you're working, and it's often something that you have to do in addition to your daily work. So I'm going to talk a little bit about the problem that I have spent like most of my energy solving when I got started using R and I got excited about data workflows. I got stuck on the very first step. This is the schematic from the R for Data Science book written by Hadley Wickham and his co-authors. And it's I think it's a really nice, succinct data workflow map. You have to import your data. Often you have to tidy it up. And then you do, I'm sure everyone on the call knows, you can transform it and model it and visualize it, and then you communicate it. And it's a great schematic. My experience in a lot of my life is that I get stuck on the import, can't find the data, or I don't know who to ask for the data, or the data's in 10 different places. And so I never really thought that I would get so passionate about getting the data, but it's definitely been something that I've spent a lot of my time in R working on. And so it started for me when I was working on state environment reporting with some excellent colleagues and colleagues in other teams. We were making those indicators, as I said, and of course, indicators, when you put them on the web, people want maps because maps are beautiful and maps are powerful. And then we were always making the maps and everyone was always looking for the shape files or what boundary do we use and where are the state boundaries and, or in my case, provincial boundaries. And it became always something that sort of felt inefficient. And so we started by making a very small, simple package that had some shortcut functions in R for producing those map boundaries that were really common for all kind of plots that you might need if you were looking at British Columbia data. And they return now, the current version returns those as SF objects. So you just hit the ground running. And so it sort of looks something like this. Literally the whole idea was like one line of code, everybody can just get a map. And so you load library BC maps, load SF, because you're going to get an SF object in return. And we have these functions that are just a single name in the package. So it could be BC boundaries or BC neighbors. It can be BC, but we'll have a look at them in a second. And so this was really handy for myself, was really handy for my team, was really handy for many colleagues in our ministry. And so the return on investment of making the package was really, really clear. We got lots of positive feedback. People wanted to add more and more maps. And so the number of available layers started to grow in the package. And it was a great insert. We were solving a problem for lots of people and lots of analysts and lots of people who touch data. And we also created a mechanism for people to add their own layers. You could do a pull request and add whatever administrative boundaries that you needed. And so it was sort of an avenue and sort of encouraging people to contribute to open source packages that they were using and build out some of those skills. But of course, once you get some data at your fingertips with one line of code, it kind of just sadly leaves you wanting more. And this is exactly what happened. It's like, now we want all the data in one line of code. It's kind of how I think the general sentiment was. In 2012, British Columbia launched the BC Data Catalog. The catalog is built with open source software called CCAN. The code is in BC Gov GitHub. And it creates a nice web interface that you can get in there and you can search for the data that government might hold, greenhouse gas emissions data or bird data or road data. and you can start searching, and it's quite a nice site. You can, you don't need to know how to code. You can click and you can download. And but because it's built with CCAN software, it also came with a RESTful API, which is a jargony way of saying it came with a way to have a computer ask the catalog itself to get the data and return it back to your computer, so that you never actually have to go to the website or click. And so as soon as they launched this, those early adopters, which wasn't me actually, with some of my colleagues, they started writing code so they could go and get that data. And one day I was having lunch in the lunchroom. This was before COVID, when our lunchrooms were busy because everyone was working in person. I'm in the lunchroom and I hear my colleague, Sam Albers, say, "Oh, I just wrote this great function for getting data right from the catalog. I never have to click anymore. I can just write a line of code." And he was sitting with another colleague of mine who I'd worked on BC Maps with, Andy Tusher, and Andy says, "Hey, I have a function too. That's awesome." And so I'm sitting at this lunch table and I'm like, "You have a function and you have a function. I want a function. I don't have a function." And it became a whole conversation about everybody deserves the function. Anybody who's working for data, it's not really fair if some people have a function, other people don't. And so that became, we basically wrote up a rationale for us spending time to build out BC data, which became, I think, probably the most productive or useful piece of open source software that I've contributed to. And so BC data is basically an R interface for our BC data catalog. It allows you to browse the catalog. It allows you to pull metadata from your data programmatically, and it allows you to pull the data straight from the catalog from your R environment. So that was exciting. It took a lot of work. I learned a ton. I'm just going to run through an example, a super simple example. So if we were on the website, we could look for some data. I don't know why I chose airports. Maybe I was thinking about flying to Australia when I built this, but so let's say there is some airports data for the province of British Columbia. And here's what we would call a record. So the record has the description and it has the business owner. And then each record can have one or more resources. I think of resources as files. There can be some spatial data, there can be some tabular data. And so with BC data, you can use our BC data get data function, and you can say, I want you to get some data from that BC airports record. And in this case, I want you to grab the tabular data, and it returns it as a tibble. So one line of code if you're not working on a slide, and you want to make people, or 2 lines at most, and you have that data in your R environment that you can start doing whatever you want to do with it. I think the real superpower of BC data, which was the work of mostly the work of Andy Tusher and Sam Albers, was that it also retrieves spatial data for you, uses a different function because British Columbia spatial data is actually in a geographic warehouse, so it uses a web feature service. So it's got a different API under the hood. But here, same thing, we're on that same metadata record. We can say BCDC query the geodata for BC airports, and it's actually returning to you the spatial data with the geometry field, which is great. But the real superpower is that if you don't want all of that spatial data, you can actually you can use BC data to query the bits of the spatial data that you want on the server side, and then just pull in the data that you want in your R environment. And this is super helpful because, as I said, British Columbia is about the size of New South Wales. When you start looking at all of the roads of New South Wales or all of the trees, it's really big data. And many of us don't want to have to take the time to pull all of that data down, or you might crash your laptop if you've got RAM or memory constraints. So this was kind of a really, really helpful for analysts to be able to query spatial data and just pull in what they want. So what I've done here is queried the airports just for a couple of the Victoria neighborhoods. And then you have to use collect because it's sort of a database. Because you've queried on the server side, you say, now I want to pull that data into my R environment. And then I run it just through ggplot and use BC Maps. And I've made a quick plot of Victoria and Saanich, 2 of the municipalities with the 1, 2, 3, 7 airports. Turns out we have a lot of helicopter airports, which I didn't know about. And what's super exciting about open source, and about making these sort of packages, is that the Python folks didn't want to get left out, and they shouldn't be. So the R people started having these packages for solving this problem of getting data. And so we actually had a consultant, Simon Norris, who had been doing a lot of work for the province, spatial work, and so he built BC Data for Python, and it's available as a pip install. And so really it's sort of building tools for everyone and evening that playing field so that everyone can get their data. Okay, so supporting early adopters and solving real problems, I think, are great ways to start to build capacity and passion and interest for data science and for programmatic data analysis. The third one I want to talk a little bit about is community, and which I think is really, really important. So this is a picture of a meetup. I think building learning communities and community practices are really, really key. Bringing people together around a shared interest and making space for learning and learning while doing, which I think is really a strong way to actually retain learning. And supporting that culture of learning. And so a number of us, and this is again not just me, I'm talking about a number of public servants who just became very passionate about learning themselves, but also helping others to learn. And so we started to hold workshops, hackathons and tutorials, anything that we could do to sort of share something that we learned. I think it's really important to establish a focus of inclusiveness and openness and safety, so that you and your colleagues can really feel like you can let your guard down and just learn and try and make mistakes and try again. And we really leveraged. We didn't reinvent the wheel, and we're still very much leveraging that carpentries model, and even using their code of conduct when we host events, and sort of establishing that sense of community around learning. And those are places where we can share that these packages exist, and try and sort of disseminate, even the playing field about that there's tools exist that help people with their work, and then get feedback on those tools so that we can make them better. All right, the fourth one. This is the hardest one because it's quite a hard thing for some organizations. It's a hard barrier, but it has been so fundamental in some of the growth in skills and adoption of data science and programmatic data workflows, and that is modernizing tools in organizations. So as I said, in 2014, the British Columbia government created an organization in BC Gov GitHub. This is the earliest screenshot that I could find from 2015. And, then we only had 8 members of the organization. We only had a handful of repositories. It was so new. Just the idea of sharing code was sort of intimidating. People had to learn Git, also intimidating. Lots of culture change, lots of legal learning in terms of licensing, sort of things that folks like myself, had never thought about. But I really think that some of the leaders who led the adoption of this tool, it was just sort of a heroic effort in terms of how it's transformed digital practices and data science in the BC government. All right. So that is BC Gov GitHub. So there are 3 things I want to focus on that I think GitHub really help with. One of them is open learning content. So it doesn't replace coming together at all. So it doesn't replace workshops or meetups, or in my opinion. But it does help those that already are making content, learning content, share it in a scalable way. It does let you help people even when you don't have a lot of time. or like document, if questions keep coming up, it's a way to answer them. And sometimes just knowing where to look for help is like the hardest thing in an organization, who to ask and where to look. So I think GitHub has created a space that everyone could access because it was open, for starting to create materials. And so one of the hardest things in the beginning, it's not so much now, but 10 years ago, was how to install R and RStudio on a British Columbia managed workstation. It's not always easy when you have, and they need to be managed. I'm not upset about that. People are working with British Columbia's most private data, health data, financial data. So I definitely appreciate that there are people taking care of that so that I can do my work and not inadvertently cause harm to British Columbians. At the same time, I want to know how to install R on my machine. And so this was one of the helpful things that GitHub helped us with. Sorry. All right, helping became easier. And so leveraging things like sharing code, gists, somebody asks you for help, rather than sort of mailing scripts and having version control back. Well, it doesn't work on my machine and it does work on yours. It just created, again, that kind of code, what it's meant to do, which is a code sharing platform. And so I found, in particular, it was just really, really easy for me to help colleagues and teammates, or to get help from colleagues and teammates where I was stuck. And finally, the biggest one is really just the nature of open code. It's really, probably the most important one, which is, and I call it the 3 C's. Like, how does it start? So, it's probably 4 C's actually. Cutting and pasting. Like, I think we maybe all start with a lot of cutting and pasting. And I hope we can admit it, right? Like, and I'm going to cut and paste from this, from Stack Overflow or from this website and see if I can get it to work on my machine. And when you do, it's like a spark of amazingness that first time when something works on your machine that worked, on a video. I think that, having GitHub allowed the transition from cutting and pasting to get by to starting to collaborate using those tools like GIS or a shared repo, to being brave enough to make your first contribution, adding a layer to BC Maps or fixing some documentation. And again, creating that safe space for folks to know that, that their contributions are welcome. And then as teams mature, code reviews. I think most of when I think about really steep learning curves, that they happen when you put together diverse teams with different backgrounds, different lived experience coding, and then they start doing code reviews for each other. And boy, everyone just really starts to learn a lot. And I just put a little circle here that you might not be able to see, that circled the R, that we're still a top language, even though there's a lot of, there's over 1.8 thousand BC public servants using GitHub from the 8 that we started with. And who knows how many repositories. Too many to count. Okay, I want to share, I know that this is a group of, who are preaching to the converted of I have to give the business case for open source software. But I often do have to talk about the business case of open source software in my day job. And this just sparked joy for me. So when we put BC data, we built it in GitHub. It's open licensed under Apache 2.0. And a few years later, after it launched, we got an email from Justin Calley from the state of Victoria State in Australia. And he, he leveraged the code in GitHub and built VicMapR. And so if you work in the Victoria State Public Service, you can do the exact same thing that I showed you with BC data, that pulling, your geospatial data for the state of Victoria. And Justin has done amazing things with this package that are different, but at the end of the day, open source and sharing allows people to not have to reinvent the wheel and, bring so many efficiencies. And so, yeah, and I hope that more and more public sector organizations start to be able to see the value of being in the open, and that the return on investment that actually brings to organizations, to not have to build your own software from scratch every time. Okay, so let's look at 10 years. This is a chart pulling data from GitHub using the GH package. It's an imperfect metric, so but it's the best I could think of. So it's from the time GitHub was launched in in 2014 to about a couple weeks ago when I pulled the data. And it's the cumulative number of repositories in the org by top language used. So a lot of those repositories will have lots of different languages in them, but this is the top language for the repository. And you can just see steady growth. They're not, they're often the same teams opening multiple repos, but also more and more teams are getting into GitHub. Data science teams are starting to use that space for code sharing and for producing reproducible workflows. And R has had a steady growth. I highlight R because that's the community that I'm the most involved in, but I know Python has had a similar story and is still seeing a similar story in government in terms of people adopting those tools. And so where are we now? 10 years later, we have many BC Gov R open source packages. I built by many different public servants from different ministries, from our social ministries, other natural resource sector ministries. They do a range of things. BC Data is the one that we spoke about for getting data from the BC Data catalog. There are some to do with modeling, and some to do with accessing hydrology data, and many more. And using Shiny and deploying Shiny apps is a workflow that's leveraged a lot by BC Stats, where I work, as well as many of our natural resource sector ministries, and it's a growing space as well. And so I think we'll just see more and more teams are seeing the value in that workflow, not just for reproducibility, but also for kind of common components. You build one app, everyone likes it. Well, let's just you can leverage that same code for another ministry can leverage that same code for for their work and save a bunch of time. The current state, I mentioned that we had launched a data science community of practice a few years ago. And really the point of that was to get away from sort of language specific. It's very clear that the data science and data literacy skills are more than R. I love R, but I also like Python, and learning version control and learning how to use Git and GitHub became something that we really needed to crowdsource and support. In particular, Git is a very intimidating software for many folks that are new to the workflow. It is mostly a digital or virtual data science community of practice now, but it's going strong. Okay, I'm going to finish with a few observations just from my time, and one of them is that growing data science and data skills, I think, in any organization or any community starts with people. So it's sort of a little bit back about the early adopters, but I feel like for me, these are some photos of some of my colleagues, and just finding those people, finding those early adopters, and supporting each other to try things out and to learn how to communicate about what you're doing and why you're doing it and why it's beneficial, I think is one key step. And also, there are many people. I think if you find yourself being the lonely data scientist in your company or on your team, or maybe you're in a public sector organization that is just starting to become data oriented, it can be difficult to find those people. And so maybe finding them outside of your organization to start. And I certainly know that I have had so much support from other communities to grow my own skills and to better understand the importance of reproducibility and how to scale it for a team beyond my own work. And finally, trust is key. I'm talking about 10 years of time, and it somehow it might feel like that's a really long time for where we're at. I don't know. But I think going at the speed of trust is really important for individuals, but also for organizations. Building that trust when you're asking people to change the way they work or build tools or think about data in different ways, you need to have trust as a foundation of that conversation. And certainly moving at the speed of trust for organizational change, or for asking your IT teams to let you use open source or GitHub. You really have to put the time in to build those relationships. And and so I think it's a journey. And at the end of the day, the relationships are more important than how fast you're making your change. Because it will happen. It'll happen. The change will come, I believe. Okay, what is next? So I hope that some of the themes for me is like, why do I care about this, and why do I spend time on some of those things that I help build data science capacity. Data literacy and improving reproducibility and auditability of public sector workflow is important for promoting transparency, accountability, and public trust. I really firmly believe this. It contributes to more informed and fair decision-making processes. It does more things not on this slide. It's more efficient. It saves resources. I think you can do things faster once you've built a foundation. I mean, the list could go on. And so what's next for me is more of the same. The BC Public Service is 35,000 people. It's very large. We're constantly recruiting and seeing turnover. So I kind of feel like I could just keep on going. But I also feel like this kind of work and these conversations are more important than ever in the face of artificial intelligence. The urgency to build data literacy and to emphasize reproducibility, to emphasize that data is from an authoritative source, and to be able to demonstrate what that authoritative source is, I think will become more and more important for organizations. If we want to be transparent, we want to mitigate risk and maintain public trust. So I sort of feel like I still have lots of work to do. Okay. I'd like to acknowledge my many BC Public Service colleagues and community members who contributed and did much of the work that I showed here, and continue to lead and do that work. And I'd like to thank the Statistical Computing and Visualization Committee for the invitation to come and speak with you today about my experiences in the BC Public Service. Thank you.
Thank you so much, Steph. That was really inspiring and also very informative as well. It's a great roadmap of how, and a great example of how to build a community. I think there are a couple of questions I can see already on the chat. If people would like to unmute and ask their questions, they're very welcome. There is a question I can read out from John Z. A very practical and informative talk. I am curious to know if Steph and her team ever use or find the statistical hypothesis testing necessary and useful in their works.
Yes. Yeah. I have, in BC Stats, we're currently working on some research projects, which is really bringing my life full circle. British Columbia put through a new piece of legislation last year, or maybe a year and a half ago, called the Anti-Racism Data Act, which enables compels British Columbia to actually collect more personal demographic data in order to be able to assess programs and policies for racism and make them better. And so BC Stats, some of that is enabled under the BC Stats Act. And so we have been doing some research in a secure research environment with de-identified row-level data. And so we definitely are using R mostly. My team is still mostly R. So the infer package and most of the usual stats packages. So definitely, it's definitely using those tools. I hope that answered the question. A lot of statistics from a Bureau of Statistics is counting things, and that's okay. Like I'm not trying to, statistics is a word that describes different things. So different from frequential statistics, I guess. And so we do a bit of everything.
And see, Di has a couple of questions. Would you like to unmute and ask?
Do you want me to ask them live? Happy to do that. I'm curious about handling how you handle data that's constantly refreshed. So some data tends to get stored in sort of a static catalog, but often we've got updates on the data on a regular basis. How do you handle that in the system?
Yeah. So real time versus batch processing, I think is maybe where I think most of the workflows that I've been involved in, and I can't speak for the whole public service. I know for like Ministry of Transportation, they must be in this space of real-time processing. A lot of the catalog, the teams, so like the air quality team, they have real-time data coming in, but they do basically a batch upload to the catalog. I think it's once a day, right? So they have all these scripts that happen on servers. And so then you can run any analysis or any public-facing product that uses that data. It would also run once a day. And so it's about working with the business owners to understand their data work, their engineering workflows behind you, and then tailoring your tools and your approaches. It's also, making sure that we're investing, like, do we really need a real-time workflow? Is that like, right, who's the audience? What is the use? And so I'd argue for public safety things like some of our, we have a thing called Drive BC, which is an app which tells you about conditions and shows you highway images. That needs to be real time, right? Because things can change drastically. So it just depends on the business area and the need. But you're right, the catalog is not the tool for that. It is a static snapshot.
So we've got a question from Franco. Thank you, Steph. I'm just wondering, what is the biggest strength you see in R comparing with Python, which is what our current data science team mainly use?
Okay.
Yeah.
So the caveat, these are just my opinions. I'm not making a statement about R versus Python. But I think I have the pleasure of having folks on my team that are really, really polyglot, like people who, and I'm if I was 15 years earlier in my career, that's where I would want to go, is just to be able to pick up either one of them. Because Di and I were just talking about, like, your workflow will really, like, you figure out what you need to do and then map your tools onto that. And sometimes you're limited by what you actually have on your team in terms of skills. Sometimes you're limited by what's the legacy code that you're working with. But for me, R is still just more elegant for, I'll call it like ETL or data tidying or munging. It's just beautiful. Like, I'm like, I can write it in Python, but it's just a bit harder and harder to read. So there's one space. And I also think that my real passion is actually on the communication side. I mean, I love all of it, but it's like, if we can't communicate our results in a way that lands with the people who actually can action them, then I sort of feel like, well, why did we do the dashboard? Why did we do the work? And I think R, especially now with Cordo and the integrated dashboard tools and be able to make websites, like, I feel like that whole ecosystem is just really quite easy and pretty out of the box for those of us who aren't designers. So I think that's also a strength. There's no doubt, though, Python is, what is it that people say? So R is the best language for statistics, and then Python is the second best language for everything. That's what I heard that somewhere, and I think it's really, really true. But yeah. And I've often found my team, and we work in an environment with billions of rows of flat file data, and I'll just ask, what's faster? I don't like, and not ever faster, but right now, given the tools we have, what's the fastest in terms of, like, do we need to wait 6 hours for a job, or if you can cut that out? Yeah. So.
That's great. We've got a question from Hassel. Often my code can seem really niche, and making it findable and usable is a lot of work. How do you get enough information to know what code to share?
Trying to find the question. Good question. I mean, so one of the digital principles of government now, of BC, of the British Columbia government, is that our work should be in the open by default. And then you should have a reason for it not being in the open. So that reason would be like public safety. You know, you might not be putting code and data for a species at risk, for example, into the open because somehow that might increase their risk. There's lots of reasons. And so, you know, I kind of start from that place. I don't know. I often put niche code in Castle because I don't get to write code that often anymore. So I just want to keep up my GitHub and Git skills, to be really honest. So you'll see me pushing, like, why is Stephanie pushing her analysis of her energy bill, you know, to GitHub? I'm like, well, it's kind of all I've got to keep my skills sharp and to learn the new, you know, they're changing the UI. So I don't know. It's a good question. A lot of the teams, or my teams, have had like a snippets repo where you might just put up niche scripts. You never know when they're niche today, but maybe there'll be something that someone needs later. And I think it also depends on whether you have like an internal code sharing platform for your team and you have an external one for production code. It kind of depends on what else is at your desk. Like the quote is that if someone said to me once, or maybe I saw it at someone else's talk, and I wish I could attribute them, but like, I think it's David Robinson actually. If it's on your laptop and only on your laptop, it doesn't, like, can't help anybody, right? And so I think, and if it's somewhere that someone can find it, maybe your niche code has a really cool function that you wrote, and it would, you never know.
Got a question. I'm just wondering, so do you find that data scientists also talk a lot between the different provinces? Do other provinces also have such a vibrant, strong data science community?
Good question. I hope so. Not all of the Canadian provinces have a statistical agency, and so I don't talk to them all equally. A lot of folks would really like a GitHub organization, and so I chat with those folks about how I think they might help get there. But no, it's not equal. And I think, you know, British Columbia has had, I don't want to toot their horn, but I think that they're really working hard in this space to be more open and transparent around all code. And as I said earlier, and maybe briefly in the talk, you know, a part of the value of BC GitHub is code sharing with developers around just, you know, being able to, like, not have to rebuild software, not just data science software, but any kind of software over and over.
Great, thanks. So
Can I jump in with a question, Melissa? Is that all right?
Of course.
Yeah, Steph, thanks for your talk. I guess it follows on from something you mentioned just a few minutes ago. I'm calling in from Perth in WA via Southern Ontario many years ago. I'm just wondering, so is BC Stats a separate agency, or where does it fit in the hierarchy? Well, sorry, the structure of the BC Public Service. You mentioned it was kind of unique in provinces in Canada, because I don't think I know of any comparable agency in Australia, and certainly not in WA.
Yeah, so we're not unique in that we are a part of the Ministry of Citizen Services. We're in a division, we're a branch, so it has all that same lingo that you would have in any kind of government British Columbia org chart. But they are the BC Stats as an office, and our authorities are directed under the BC Stats Act, which I'd have to Google for you.
Right. So then just follow-up question then. Yeah. Oh, I'm just going to say, so what sort of, over time, what kind of approval did you need? I mean, was it ministerial approval to do what you needed to do, or was it the directors of if that's the structure or the term that you guys use in BC, is it the directors of the different departments from whom you needed to get approval for building the infrastructure and for allowing different public servants across different agencies
Yeah.
to use the various repos and so on?
Yeah, great question. I'm glad that you asked it. So in BC Gov GitHub, one of the repos that's pinned at the top is the policy guide for using BC Gov GitHub for BC public servants. And you can poke around in there and see, I mean, there is guidance around licensing, around all code that is written by BC public servants on work time is the copyright of the Crown and things like that. And it talks a little bit about like approval chain for starting to work in GitHub, and particularly for publishing code that's already written. So say you have a bunch of code that's already written and you don't know the provenance of that code, before you can license that under Apache 2.0, you really have to show that it's yours to license and you didn't maybe hire a vendor to do it and they held the IP and copyright. So there's quite a bit of that stuff that goes on in the space, and it's pretty well documented in that policy guide.
Finally, what sort of barriers did you have to kind of overcome? I think public service organizations tend to be small c conservative just by nature. So do you have any war stories that you might be able to relate that would help those of us who are trying to convince our own state governments to do what you guys are doing?
Yeah, I think you've just said it. The barrier is risk aversion, sort of, and lack of a common understanding around what the tools are. One of the biggest barriers, I think, for code sharing is the perception that means we're sharing data. So I say, oh, the code for this analysis is in GitHub, and even to this day, that can be confusing to some people about, like, you put the data on the website kind of thing, right? And so I think that there's a bit of like literacy around the connection between analytic code and the ingredients that you need to run the code, and so that's a big one. And yeah, I think this is when I come to the speed of trust, like finding people who can communicate the return on investment to your organization. And a big one that I didn't speak to on this talk, that I'm glad that we're having this conversation, is around recruitment. And so I don't know what it's like in Australia, but in Canada, despite the challenges post-COVID and maybe the current challenges with the tech and data private sector, recruitment is still an issue, trying to bring in and maintain data and digital skills. And so if we don't, people are trained now, you do a master's of data science at an excellent institution and you're learning Git and GitHub and you're using chat, you're using some, large language model and all of these things or like Microsoft Copilot to help you code. If we don't have those modern tools, then people aren't going to want to come and work with us. So I think that's another one that I would really think a little bit about in terms of a business case.
Okay, great. Thanks. I mean, here in WA, we're trying to compete with mining company salaries, and so we just can't.
Yeah, I think, I think there's a lot of folks who want to work for the public good, as long as you can give them a reasonable salary. But I actually think people really want to work with good tools. So, and that's a cheaper one to fix than matching salaries of mining companies.
Yeah, thanks very much, Steph.
I know we're up to the hour, but can I just squeeze in one really quick question? I'm just wondering, you referred to ChatGPT a couple of times, and I'm just wondering, do you have any policies regarding the use of ChatGPT? Obviously, you're not able to put data into those algorithms, I assume.
No, you assume correctly. Yeah, and so I can, it's actually, so we have, right now we've got interim guidance for the use of those sort of tools, and I think the Canadian government, which you can find online, which I can share with you later, has actually published already guidance for the Canadian government. And so, you can't put personal information, you can't put confidential information, you can't put data. So that the utility of those tools is pretty limited on, for government work at this time. It's still pretty useful if you have a question like, summarize how great R is, something that's like got nothing to do with your work, but you need to write 3 sentences about how great R is. I find ChatGPT can be a helpful starting place. So, but it's a conversation that we're all public sectors, I hope, and I'm sure are having. And so, and then to me, it comes back to that, like understanding the difference between data and information and code becomes pretty important to guide those discussions.
Yes, definitely. It's I work at a medical research institute, so we also have these issues coming up too.
Yeah, it sounds like the EPA of Victoria is the place to go. They've already got Copilot piloted. That's amazing. Well done.
Yes. Well, thank you, Steph, for this talk, and also thank you to everyone for your questions and discussions on chat. Well, hopefully, thank you again, and maybe hopefully we'll see you in person in Australia soon.
Maybe one day soon. Thanks, everybody.
Thank
Happy
you.
Friday.
Bye.